Every time an enterprise uses a commercial AI, they pay a toll. Right now, the industry standard relies on closed cloud models, where companies pay recurring per-token API fees to essentially rent intelligence from massive server farms. Relying on this centralized infrastructure creates three major friction points for businesses. Computing costs scale endlessly with usage, data transfer creates constant network latency, and critically, organizations must transmit sensitive internal data to external servers. This closed-door operation is highly lucrative, and it is the exact financial premise backing OpenAI as they prepare to file their public S-1 registration with the Securities and Exchange Commission ahead of their initial public offering. On August 10th, Meta released Muse Glimmer under the permissive Apache 2.0 license. By providing unrestricted commercial access to the model weights, Meta introduced a high-performance alternative to the proprietary systems that dominate the market. Muse Glimmer is a dense 29.6 billion parameter model. Rather than being built for simple conversational chat, it is engineered specifically to execute complex, multi-step agentic workflows, meaning it can formulate a plan, write code, and correct its own errors automatically. What makes this release an industry threat is where that thinking happens. Unlike its cloud-dependent competitors, Muse Glimmer is designed to run entirely locally on standard consumer hardware, operating at zero marginal cost. By giving away a highly capable, locally executing agent for free, Meta eliminates recurring API fees. This introduces a structural threat that actively undercuts the multi-billion-dollar valuation premise of closed API companies. Fitting a brain this large onto a desk is a physics problem. Running an uncompressed 30 billion parameter model at standard precision requires over 55 gigabytes of video RAM. That immense memory requirement prices out almost every standard computer budget. Historically, this meant enterprise AI agents were strictly confined to massive cloud-hosted data centers. To solve this bottleneck, Meta engineered highly specific 4-bit quantized configurations, essentially compressing the model's mathematical weights to save space without losing its core reasoning skills. The most important of these is the K-quant 17 gigabytes target. Shrinking model weights to fit exactly 20 gigabytes lets Muse Glimmer run on standard 24 gigabyte graphics cards. The distinct 4 gigabyte empty space handles key value caching and visual processing. Meta also added DFlash, a speculative drafter proposing blocks of up to 16 tokens for instant verification. By using this speculative drafting, Meta accelerated generation speeds by 3.1 times, achieving 233.4 tokens per second on an RTX 5090. By solving the local memory bottleneck and eliminating output latency, Meta effectively transforms a standard office workstation into an autonomous AI execution server, severing the enterprise dependency on cloud computing. Speed only matters if the output is actually useful. To function as an autonomous agent, the model has to execute complex sequential operations, formulating long-term plans, invoking software tools, and recovering from execution failures. To interact directly with human systems, Muse Glimmer features native visual perception, powered by a dedicated 1.8 billion parameter vision transformer built directly into its architecture. This visual encoder lets the AI parse user interfaces, interpret screenshots, and analyze diagrams natively. It navigates human software without sending images to external clouds. To pack all of this reasoning into such a dense footprint, Meta utilized a 3-phase distillation pipeline. They essentially took the highly advanced logic and problem-solving patterns from their massive frontier model, Muse Spark 1.2, and transferred those behaviors down into Muse Glimmer. The distillation worked. On the SWE Bench Pro benchmark, which measures real-world software engineering capabilities, Muse Glimmer scores a 51.2%, matching the performance of much larger previous-generation foundation models. Meta compressed the capability of a massive data center-scale AI into a footprint small enough for a high-end laptop, entirely commoditizing elite automated software engineering. Running a highly capable agentic model locally eliminates the need to transmit data outside the organization. For corporate IT, this means all processing occurs within their own hardware. This diagram illustrates the new security perimeter. Organizations in highly regulated, privacy-sensitive fields like defense, healthcare, and finance can now deploy automated agents directly onto their internal codebases. Their confidential spreadsheets and network configurations are processed locally, completely isolated from the outside internet. This creates an immediate economic ripple effect. Enterprise IT departments are expected to stop spending capital on recurring API subscriptions, reallocating those budgets toward edge computing architectures and local high VRAM graphics cards. But the ripple effects extend far beyond corporate IT budgets. In an accompanying manifesto, Meta CEO Mark Zuckerberg framed this release as a direct countermeasure against the flood of low-cost open-source models coming from Chinese developers, like Alibaba and DeepSeek. Zuckerberg explicitly warns U.S. policymakers that placing heavy regulatory restrictions on domestic model distillation and open-source development will backfire, effectively handing global technological dominance straight to state-supported foreign adversaries. By giving away models that can rival proprietary API performance, Meta is actively commoditizing the underlying execution layer of artificial intelligence, forcing intense downward margin pressure across the entire commercial AI sector. The release of Muse Glimmer is a direct assault on the economic foundations of the closed cloud model. By eliminating the network latency, the privacy risks, and the recurring costs, Meta strips leverage away from centralized tech companies and hands it directly to the end user.